This is question 8 from the 2020 higher level mock exam to do with electrical power and generation. So part A1 asks you for the current output from the transformer using the information given here. The way I've solved it is I have assumed 100% efficiency to start with, so that would mean that the power on the primary equals the power on the secondary, VI equals VI, and I solved for the current that would have been on the secondary had it been 100% efficient, but then I multiplied it by 0.96 to scale it down to find what the current actually was. You could also use the 0.96 up here in the equation to get the same answer. Next part asks about why it is useful to step up the voltage so much, and we already know it reduces power loss. The Mark scheme is very specific that you have to mention that it's thermal power loss or loss to heat or joule heating, and cannot just say that you cannot just say that power dissipation is equal to I squared R. That's for one mark, and then the second mark is the idea that putting the voltage up brings the current down and therefore reduces the losses due to heat. The next part of the equation of the question has to do with an AC generator where you're given information about the dimensions of the arrangement. And the first part for 3 marks, you need to explain why you do generate an electromotive force as it turns. So the mark scheme includes 4 different points, of which you need to mention 3. And so the first important point is that as it rotates, you get the change in flux. You could also describe the lines of flux being cut by these sides, A, B, or C, D. You can take either approach. The next statement is the Faraday's law statement that the induced EMF is proportional to the rate of change of flux or the rate of cut of the flux lines, depending on which approach you've taken and answering. The mark scheme is very clear that if you don't have the word induced, you cannot get 3 out of 3 on this question. And then for the third mark, you could say that the induced EMFs in A, B, and C, D are both in the same direction around the loop, and therefore will add together. Or another direction you could take is just to say that a sinusoidal EMF or an alternating current EMF is actually produced as it rotates. Next part of the question are rather straightforward calculation questions. So they want for just one wire, what is the induced EMF? So that's a straightforward BLV where you have the strength of the magnetic field, you have the length of wire between A and B, make sure you convert into meters, and then the speed that's given as well as 2, so you get 0.058, and then the total instantaneous peak. For this one, you need to take this, whatever value you get here, and use it. Because there's the 2 different wires at the same time, it's that answer times 2, but also in the original question, it mentioned that there are 80 turns, so you need to use that aspect as well to get an answer of 9.2. Mark scheme also says 9.3 and 9.6 are accepted. I assume that these would come from round-off errors.